Hello everyone. So today we are going to discuss problem 3350 of Leetcode. And yeah, if you have solved the problem that was given by Leetcode yesterday, then this is the this is almost same problem. Just the difference is that you have to find maximum possible value of k for which you have two adjacent subarrays, adjacent increasing subarrays to be more precise. So if you have not read the question, I will read it for you. So we are given an array of array nums of n integers, and your task is to find the maximum value of k for which there exist two sub arrays, adjacent subarrays of length k each, so that both subarrays are strictly increasing. Similarly, check if there are two subarrays of length k starting at indices I, a and b, such that a is less than b. Okay. So indices a is less than indices b, and both subarrays nums from a to a plus k minus 1, which means length k, this is increasing, and then b to b plus k minus 1 is also strictly increasing, and b is equal to a plus k. It means that you jump k indices from a and you get b. Okay, so we have to return the maximum possible value of k. So do you remember how did I do the question yesterday? Like yesterday, in yesterday's problem, we were given a k. We were given a k. We didn't have to find. We were given a k, and we have to find that if there exist any two adjacent subarray such that those both subarrays are increasing. So what I did, and the constraints were also n is equal to 100. So what I did, I was just doing brute force. I started from I is equal to 0. Okay, I check if from I is equal to 0 to I plus 0 plus k minus 1, it is increasing. And then from k to k plus 2k minus 1. Okay. From k to 2k minus 1, is it increasing or not? So that I was doing in yesterday's problem, brute force. And today also I thought of doing brute force. Okay. I made a check function. You can see it. Okay, so this check function checks if we have any such wait. Okay, okay. So in check function we will be given I. Okay, and we have to tell if from I to I plus k less than I plus k, which means length of k, a subarray of length k with starting position as I. So we will check that if it is increasing or not. Okay. So this is my check function. Now what I do binary search. I will create two. Uh, okay, I think I should use a whiteboard if it's becoming confusing. Okay, wait a bit. Okay, so first of all, I want to tell you that binary search will work. Why? Let's say that you have a subarray of length k, okay, which exists. It means what if I'm saying which exists, it means that you have a subarray which is increasing and its length is k. And you have basically two adjacent subarray of length k such that they both are increasing. Okay. So I'm claiming that you will also have two subarrays of length k minus 1 that is increasing. Okay. This thing I'm claiming. And you're thinking like how you can say that? What is the proof? So let me show you something. Let's say 1, 2, 3, 4. Okay. Uh, let's say k is equal to 4. It means that you found a subarray, two adjacent subarray of length 4, and they both are increasing. And let's say 2, 5, 6. So 2, 5, 6, 7. Yeah. So you can ask me that, okay, this is increasing and this is also increasing. This is for k equal to 4. So I'm saying that for k in this in this whole array, for k is equal to 3 also, it will exist. How? Now you will say that we go from 1 to 3, okay, it is increasing, but 4 to 5, it's not increasing. 2, 3, 4 increasing, and 2, 5, 6 is increasing. So you can see this for k is equal to 3 also it existed. And you might again ask that, like, this is not a proof. You just gave an example and you are just showing me that, yeah, it's true. But how can you prove your statement? So I can prove you using this thing. Let's say you have an array of size k and another array of size, sub array of size k, and they both are increasing. So I'm saying that for k minus 1 also, we will have in this whole array, we will have two adjacent surveys, okay, of length k minus 1 that are increasing. I'm claiming this, and how I can say that? Let's say if this whole array is increasing, this whole subarray from here to here, if it's increasing, then I'm claiming that from here to here also is increasing. Like you just decrease one element from this subarray, and its length become k minus 1. And you decrease one length from the end of the another subarray, and this also becomes k minus 1. So they both are still increasing. Okay. And for still, if for k minus 1 it's increasing, then for k minus 2 also it's increasing. So binary search will work. Okay. What I'm saying that it is a predicate function. Okay. And if we see a predicate function, then binary search is applicable. Okay. So now what I did, I'm just telling you like which didn't get accepted. It gave me TLE at 1106 test case. Test case. Okay. I was creating a check function. Okay. So I was creating a check function. I was giving a parameter I. Okay. Parameter k and parameter nums. Okay. The vector. Then I start from left is equal to 0 to right is equal to n by 2 plus 1. Okay. And why I'm writing n by 2 plus 1? Because k can be at most n by 2. Okay. And why I'm doing n by 2 plus 1? It's, basic binary search. Okay. So in predicate function, our answer is like this t t t t t f f f f f. Okay. And I am starting my left from here and right from here. And when we do L plus R by 2, which means we go to mid, then we go in the valid search space. Okay. Like if you are still having issue in this thing, I can make a video. You can just put in the comment. So this should not be a problem. That's why I'm writing left is equal to 0 and writing 1 by 2 plus 1. Now I do my binary search while right minus left is greater than 1. Then my mid will be left plus right by 2. Okay. Now this is my k that I'm considering. And for that mid, I will check if there exists any subarray, any two adjacent subarray, such that length of those both subarray are k, mid, and they both are increasing. So what will be my time complexity for this particular thing? Let's say that you are checking for mid. Okay. a particular mid. So you will go from I is equal to 0, then I plus mid minus 1, I plus plus, and you will just check that if it is increasing. Okay, then you will go from I plus mid to I plus 2 times mid minus 1, I plus plus, and you will be checking that if another subarray is increasing. This thing you will do for for each I. So I think n times mid must be time complexity for this into how many times we are doing this binary search, which will be log of n. Okay, log of n by 2, like you just can consider log n. So this can give you a TLE because n is 1e5 or 2e5, I don't remember exactly, but let's just consider it's 1e5. And our mid can go from 1 to 3, like it can go up till n by 2. And when it's, let's say, n by 2, then we can still consider it 1e5, okay, or 1e5 by 2, and 1e5 times 1e5 will be 1e10, which will give us a TLE. Okay, so now I know one thing for sure, that binary search will be used because we have to find maximum k, and this particular statement gives me a hint that I have to use binary search. So can I do some intelligent binary search? Yes, I can do. And how I can do it? Let's see. Suppose that what we are doing in this check function, we are going from I is equal to 0 all the way up to I plus k minus 1 and checking if it's increasing. How about if we already know that at this particular I, this suppose that this is some particular I, and I know the maximum maximum. Okay, this like let's just write maximum length of increasing subsequence, or no, not subsequence, subarray. It means that up till I, let's say I'm at index I, and I know maximum length of any subarray up till I. I know this thing for sure. So if I know this, then what I can do, I can also know for I minus k. Okay. So are you able to understand what I'm trying to say? If you know maximum length up till I, okay, maximum increasing subarray up till I, let's say it's greater equal to some k, and up till I minus k also, it's, let's say, length is greater equal to k, then I'm damn sure that it in this array there exists two adjacent subarrays which are increasing and their length is k. I'm damn sure for that. Okay, because if it's greater than k, then it can be k plus 1, k plus 2. I don't care. If it's greater than k, then for k also it exists. We just proved that. And so my dp of I, okay, it will be longest increasing subarray till ith index. Okay, and whenever we are doing the check function, okay, I will be given an index I, and I will have to tell that if there exists any any two adjacent subarray. Okay, not this I. Okay, let me ask you something. Let's just close this. Suppose that you want to check that in this particular subarray, is there exists two subarray, adjacent subarray, which is increasing and its length is k. So how will you find it using this thing? How will you find it efficiently? Initially, we used to, make that check function and do the brute force. But in this case, how will you do? I will start from I is equal to k all the way up till I less than n, I plus plus. Okay. And then I will check if dp of I is greater equal to k. It means that length up till ith index is greater equal to k, and dp of I minus k is greater equal to k. If this is true, then I will return true. If for any I from k up till n, if this thing is true, then I will return true. Okay. And why I start from I is equal to k? In order to, not go out of bound. Okay. So this is the minimum index from which the second subarray will start. Okay. I could also do it like this. I started from I is equal to 0, and then my I plus, what I should write, k is less than n, then I plus plus. I could also start from left. It means that my left subarray starts from 0 and goes up till I plus k less than n. Okay, I could also do this. So I'm gonna do this thing, dp of I greater equal to k. So, okay, this was the solution. And now I'm gonna show you how it goes. I'm not sure if you can see it. Okay, let's just consider that you can see it. So I created a check function. Okay, let me close this. Let me share my screen again. I will just share this screen again. Yeah, okay. So I created this check function. It goes from I is equal to k up till I less than n. And I will check if dp of I greater equal to k and dp of I minus k is greater equal to k. It means that the second subarray starts from I is equal to k. Sorry, not start. It ends at it ends at I, and you are from I. You will check that what is the maximum length, and then from I minus k, you will check what is the maximum length. And if they both are greater equal to k, then you will return true. And if you didn't find any such I, you return false. Now you just create a dp vector, okay, initialize n, and this is the calculation of dp. So I'll say this is transition state. So if, okay, so this is my base case, that length, first we'll consider the length of every subarrays, like length of every dp of I is equal to 1 for each I. Why? Because let's say that we didn't get any subarray of increasing subarray of length 2 or 3, it was just 1. Okay. And how it can be possible, like zigzag. Oh yeah. Okay. If you have a zigzag array, then this will be possible. So you just calculate dp like this, dp of I is equal to dp of I minus 1. So maximum length up till I minus 1. And if num size is greater than num size minus 1, then for dpi, you just add 1. And then this is my binary search. If check mid of dp, check mid comma dp comma, and like we for this particular k, this is k, we check if there exists any index I such that there exists two adjacent subarrays of increasing subarrays of length k. We check this. And if it is true, then we go to left is equal to mid. And if it's not, we go to right is equal to mid. And finally, we return left. So that was all for this solution.